Bismillah ar-Rahman ar-Rahim. Welcome everyone, and in this recorded video we are going to be taking the preparation for test 2, and as I have sent you in the Teams, that this is not a replacement of the PowerPoint presentations. It is just a tool that supports you to prepare yourself well before the exam. So let's start, and just to cover up what I'm going to be covering, give you an idea. So we are going to go through the multiple choice questions, and we're going to go to the problems, and in this case the equations that you will need to solve the problems. And as I said, that you'll be getting the equation sheet to support you in solving the problems. We are going to go through some case studies as well, just to extend that knowledge and to reflect what you have studied as applications in real life. And then we are going to also go through some kind of a summary of what we have went through out for our exam. If you can recall, now that chapter 2, test 2 includes both chapter 2, which is to do with signal conditioning, and if you also can recall, we also went through chapter 4 and 5. That is to do with sensors and transducers, and make sure that you go through the PowerPoint presentations. Now let's warm up with our questions. For example, we have this MCQs, analog signal conditioning. What is the main purpose of the analog signal conditioning? Well, main purpose of the analog signal conditioning is that if I have a signal, I need to condition it so that it can be used. That's the idea. And why to condition if the signal is already ready to be used. In this case, so amplified digital signals. This is not true, because usually amplification is only for analog signals. However, to convert a sensor output to a usable form, this is exactly what you want. Why? Because the output of the sensor, which is an analog signal, is converted to a usable form that we can use. To process only pneumatic signal. Now this is somehow looks like correct, but because it says only, so it's not correct. And looking at pneumatic signals خلاص يعني it is already a usable form. So if it's a usable form, why should we also convert it to something else? And then the last one, to measure. Of course, there's nothing to do with measurement in the analog signal conditioning. So that's part 1. For example, part 2, what does the term loading? And here when we say loading is different than self-heating, if you can recall. So loading is like the voltage input that it has, whether self-heating that comes from the resistance that is within the sensor because of the resistor. So in this case, when we talk about loading, we are talking about the voltage that is due to the load. And definitely it's not amplification or the non-linearity in the signal. So the answer is B. The low pass filter, it passes the low frequencies, and in this case this is very clear mentions here, but we want to also ensure that it's not only passes low frequencies, but it blocks the high frequencies, and definitely B will be the answer. Sensors and transducers, the thermocouple works on which principle? Well, thermocouple it depends on the Seebeck effect. It's not the piezoelectric, which depends on the piezoelectric stone, whatever you call it, the material. It's not the thermal expansion, which is to do with something that expands because of temperature, and thermocouple has nothing to do with this. And definitely the Seebeck, because capacitance is something else. What is the output of a strain gauge? Well, now we know that when you strain something, is pulled out from both sides or pressed in some way, the resistance of that changes. So definitely it will be resistance change. Which type of sensor is suitable for measuring fluid flow using electromagnetic principles? And now the answer is very clear, because it says electromagnetic, so it's the electromagnetic flow sensor. Filters, what does the cut-off frequency? So now we are talking about the cut-off frequency of the low-pass filter. So here the cut-off frequency, it is the frequency which cuts off, which is so what I'm cutting off. I am cutting off the high frequencies and letting the low frequencies pass. So let's see the frequency below which signals. Now below means that it is cutting off the low frequency, which is not correct. The frequency above which signals are blocked. Okay, now this is where it is blocking the higher frequencies above. And here it says the frequency which the filters gain its maximum bandwidth. It's nothing to do with the question. Wisdom bridge. In the Wisdom bridge, definitely what we have, the output voltage is 0. The null voltage is 0 when we have the ratio of R1 to R2 is equal to R3 to R4, or R1 divided by R3 is equal to R2 divided by R4. So it is the ratio of resistance in one branch equals the ratio in the other branch. I just crossed this because this was also like a correct answer, because if all the resistances are equal, that also will satisfy that the ratio will also be satisfied. So I just cross it out because it's like we having two answers in one place. RTDs, now this is a resistance, RTD, temperature detector. So very clear, you are talking about the resistance. And RTD is used to measure what? Is used to measure temperature, not the pressure, not the displacement, not the fluid flow. I just removed the word high because I know that it can measure high temperatures, high frequency, but it's enough to say that it measures temperature, which is the main part here. Which of the following statements about the thermistor is true? Well, we know the thermistor is non-linear, and it has an equation, and this equation is exponential. And in this case, part C is very clear. It is the right answer. It has a predictable exponential relationship between the resistance and the temperature. Now, if I go to part A, resistance increases linearly. No, it's not linear. It is less sensitive to temperature. No, it's more sensitive compared to RTDs. It generates a voltage. Well, it's about the resistance that change. It's not generating a voltage. Yeah, we are measuring the voltage, but it's not generating a voltage. Okay, so there's a difference. So that's very clear. Piezoelectric sensors, it depends on the piezoelectric. So piezoelectric is like you're pressing mechanical stress. You're pressing on the piezoelectric material, and based on that, you're having the output charges or the electric charge. So this is part C, very clear. A capacitive sensor depends on the medium, and a capacitive level sensor. What happens when the level increases? Well, when the level increases, definitely what I'm going to have. When the level increases, I have the capacitance will increase. Signal conditioning. Again, why does the capacitance increase? It increases because you're having the medium transfers the more charges between the two plates that acts as a capacitor. Signal conditioning. What is the primary purpose of signal conditioning? Well, again, this is very clear. We want to modify the signals to meet a requirement, to be something useful so that we can use it. So this is another way of explaining it. In a differential amplifier, common mode signals are well, now we have a differential amplifier amplified with a different signal, completely rejected. Now we are talking about the common mode signals. Maybe this is a terminology that I didn't use in the class. Maybe this is why it's confusing. But what we have is that you're comparing two different signals. It's an equation. It's an equation where we use differential amplifier so that we can satisfy the equation or the signal conditioning that you are aiming to do. In this case, now what is the common? Reduced significantly compared to different signals. So this is what usually we have. It's like reduced. Why does the voltage reduce? The idea is that because you have resistors and this somehow acts in reducing it. But I would say that it depends on the amplification. Differential amplifier, okay, so amplifier amplifies, but talking about the differential, because it takes the difference, and maybe this is the why it is reducing it. But somehow I don't feel that this is very clear to answer. What physical property is directly measured by ultrasonic sensor? That is very clear. So ultrasonic sensor sends an ultrasonic wave and it comes back. So the time that it goes and come back. So here the time of the flight of the sound waves goes and comes back. Now we have the speed of the sound, and we also know the distance. Well, it's not we know the distance. We will calculate the distance, which is equal to the speed of the sound times the time that I'm already getting here. And by distance, I mean the level. So this is used for level measurement. Now, sensors and automation, which of the following sensors is best suited for detecting liquid level in the tank, corrosive chemicals? Now, when you say corrosive, anything which has some kind of an interaction, getting in contact could be a problem. Now, last one is a bore and tube pressure sensor, though it's nothing to do with the level, so we can cross it out. Ultrasonic sounds good because it sends a signal and gets it back. Now, capacitive level sensor, it also has charges. So it sounds good as well, but we are still worried about corrosive, the word corrosive, because it's in contact with the plates. That will be a kind of a material that will transfer charges, and maybe that material will get corroded because of the corrosive material. Now, float is direct contact. So very clearly, ultrasonic is the one which doesn't have direct contact, is good for corrosive chemicals. Thermocouples. Now, the thermocouple, as we said, it has the Seebeck effect. It produces voltage based on the two dissimilar materials. So the voltage generated by a thermocouple depends on the type of metal wires used. Yes, it depends on the metal wires because two dissimilar materials. The temperature between the two junctions. Yes, one is the reference and the other one, which is the one that we are measuring or changing. The resistance of the circuit, nothing to do with the resistance. RTD, yes, it has to do with the resistance. Thermistors, yes, it has to do with the resistance. Thermocouple has the Seebeck effect. It has two dissimilar materials and the temperature difference. And when you multiply the Seebeck effect with the temperature difference, you will get the electromagnetic force or the voltage. So both A and B are the answers. Low pass filter, again, you're passing low. And you're cutting off the high. So allow a low pass filter with a cutoff frequency of 1, which means that anything higher than 1 will be cut off. So in this case, frequencies, okay. So it says here frequency below will pass. Okay, so frequency below 1 kilohertz will pass. So that is the answer. Or we can say frequencies above 1 kilohertz will be cut off. Okay, so that could be another answer. Sensors, which sensor is the most commonly used for detecting rotational speed? Now, the rotational speeds, we have the tachometer. If you can just go back and see. RTD is temperature, thermistor is temperature, and piezoelectric sensors, mechanical stress. It could be due with for the pressure, for example, in this case. But definitely, it's nothing to do with the rotational speed. Now, the piezoelectric applications. Again, it's like a mechanical stress that gives me voltage, and in this case measuring static pressure. So the static pressure, something which is pressing, it's not dynamic, which is always changing. Okay, so it's not for vibration. And mechanical stress, okay, so that is confusing now, so I'll cross this because it's either A or D, but when you put both of these, it just gets confusing, so I need to put one answer only. And the capacitive sensor, the capacity of a capacitive sensor increases one, of course, when we have the dielectric constant, which is the material which is in between the two plates, it's increasing. So definitely C. Now the area of the plate decreases, no. If the area of the plates increase, the distance between the plates increases, actually no. If the distance between the plates gets closer, there will be more charges, so more capacitance in this case. The voltage applied increases. Again, it's not about the capacitance here, it's only talking about the voltage, so this will not be applied, so definitely dielectric constant. RTD calibration, well, this is a bit tricky, but what do we have in RTD? It's a resistance that is related to temperature, resistance temperature detector. So the relationship between resistance and temperature should be always correct. Now, calibration means what? We calibrate it to make sure that this relation is correct between the resistance and temperature. Okay, so what answer I have? Resistance and temperature here measures its resistance at two known temperatures. I'm just verifying that the relationship that I already have between resistance and temperature is correct, so it's part C. Ultrasensor limitations. So ultrasonic sensors are at least effective for detecting. Yes, it's effective, and again we said that It's very effective. It sends sound waves and it receives it back. So they are least effective. Okay, least effective. Now the least effective, which is less than others, why is it least effective? Maybe the sound waves are scattered. Now where does it scatter? Or I can see there's another answer here. Absorb sound waves. So imagine you're sending the sound waves and it's absorbed. So you cannot really achieve your goal. You cannot receive it back. So that definitely this will not work. Now solids will act as scattering, but here it says with smooth surfaces. Because it said with smooth surfaces, that's why I couldn't identify this as our correct answers. Now very small objects, even if it was solid, it will be smooth in this case. Transparent liquids, again, it has nothing to do with transparency, rather than if it reflects or it doesn't reflect. So definitely D is the answer. Signal amplification, an instrument amplifier is commonly used because it amplifies only C signals. No, that's not correct. Rejects common mode noise, yes, and amplifies small different signals. So that is the part that I'm looking after. Converts digital signals to analog, this is not the answer. Directly measures pressure, this is not the answer. Maybe this is confusing for you, but when I'm amplifying the signal, I'll try to not amplify the noise. So I'm rejecting the noise and amplifying only the signals. But we may need to add some kind of a filter before the amplification also. And this helps so that I can reject the common mode noise. Now noise filtering, 60 Hz notch filter. When you say notch, that means there's high and low. It's used in signal conditioning too. Now, what do I want this in this notch filter? I want to remove the 60 Hz power line interference. So anything that is interfering other than 60 Hz, I do not want it. Maybe we do not concentrate on noise filtering. We talk mainly about the low and the high, but a notch is just a notch. So I think so. You got the idea that the 60 Hz, we want 60 Hz. So we don't want interference with the 60 Hz. So we don't want to amplify the signal. We don't want to pass the signals above 60. We don't want to block the signals. So it's not only passing, it's not only blocking, it's removing any interference with that 60 Hz. Okay, so thermostats is mostly commonly used for, well, measuring temperature. That is very clear. So monitoring battery temperature, let's see here. So measuring high temperatures in kilns, well, thermostat is not good for high temperatures, but maybe for battery temperature, so that makes sense. For example, think about the battery temperature inside your car. Analog signal conditioning. So now that was the first part, which is to do with the multiple choice questions. So I hope that was clear. And let me stop the video here and we'll continue with the problems in the second video.